Saxon Algebra 1, Lesson 25, Solving Equations. We've been solving equations for a long time. How can we possibly have a lesson on that topic as if it was new? Well, it's not new, it's all familiar, but it's an important lesson, so we're just going to talk about it again. There are two rules to solving equations. We use them all the time. We don't usually put them in words like this, but they are two of the three basic rules of algebra, so they're worth reminding ourselves. And I'm writing them in shorthand. The first one is that you can add or subtract any number to an equation as long as you do it to both sides. Right? Got to keep that little pup in balance. So add or subtract any number. The second rule is that we can multiply and divide an equation as long as we do it to both sides. Yeah, I'm going to say that in a second. But the thing about multiplying and dividing is it has to be a non-zero number, which means any number but 0, right? And then we also have to remember to do it to both sides. Now, why a non-zero number or 0? Why can't we use 0? Well, dividing by 0, we know that's a problem, right? It blows up the kingdom. It implodes the universe. We can never divide by 0. So it should come as no great surprise to us that we can't divide equations by 0. Multiplying by 0 just turns everything into a 0, right? So if we multiply our equation by 0, we're basically just stripping all of the value out of it and turning it into, it's like a factory reset, you know what I mean? It destroys all the content. So that's the only special rule that goes with multiplying and dividing, is you can't use 0, but everything else is exactly the same. Okay, let's do some examples. 25.1. Now, whenever we see the word solve at the beginning of, or at the instructions of a problem, that tells us that we have an equation, and it tells us that our goal is an answer that looks like x equals fill in the blank, right? And it might be a y and it might be a t. I mean, it's not always an x, but you know what I mean. It means there's a letter in the equation, and our goal is to get all the numbers shoved to one side and the letter by itself so that it looks like this in the end. So the first thing that we want to do when we're told to solve an equation is take a look at what we've got. Now, I can see right away that this is an equation, right? My brain goes to the equal sign, and I see, yep, sure enough, that's an equation. Later on, we'll know that there are some rules that only work if we have an equation. So that'll be important for us to notice. The other thing we want to pay attention to is, where's the letter? There it is. All right? So we know we're looking for that little guy, and we want him by himself. So this is where we do the best friend go home, or these are the three friends, right? And this is the one that has to go home first. 4x equals 12. All right, that's the third friend. Oh, it hurts to be that third friend, doesn't it? Because you know the other two are closer than you are, and it's hard. I found myself in that situation. I hate it. But now we've taken care of that. Now we're ready to divide away that 4, and we get x equals 3. So just as I said, our goal is to create this kind of a solution, and that's what we did. Remember, here we know that we're multiplying 4 times x, so the opposite of multiplying is dividing, just like the opposite of adding is subtracting. Let's do another one. Copied it down. John says to solve. Yep, there's the equal sign. We know it's an equation. Here's our variable. We're adding to it and we're multiplying by a negative number. Okay, we always do the adding and subtracting first. And remember that I want you to copy my format exactly. Exactly. The way I draw lines, the way I cross things out, the way I line things up. Make sure you're doing it just like I am. This is slightly squishy, but we divide by -5. Don't worry about the plus and minus signs and trying to make sense of it. Just know we always divide by, we always divide by the exact same thing that we're multiplying by. So we're multiplying by -5, so we divide by -5. Same thing over here, and we get m equals -2/5. Notice that over here, I kind of had the minus sign attached to the 5, right? But when I wrote my answer, I pulled it out and I floated it. That's the way we typically do that, right? During the calculation, the minus sign belonged to the -5, but as my answer, as much as I hate to float numbers, I'm very happy to float minus signs. Okay? And we have 6 examples in all in this lesson, which is quite a few, but that's all there is to this lesson. You'll discover in Algebra 2, there are lots of 2-part lessons, which seems very cruel, but that's how it works. Okay. This one has a lot of minus signs floating around. Our variable is a k. Last time it was an m. Guess what, you guys? It doesn't matter at all. Just whatever letter it is, roll with it, okay? These minus signs, we're not going to let them throw us either. We're just going to handle each calculation as it comes our way and make the best of it. So the first thing we want to do, there's our k. We'll take care of the adding and subtracting part first. We'll add 4 because that's the opposite. Write it on both sides. That's going to cancel. -7k equals, now let's see, we're down on ladder -21 in the meadow, and we're going up 4, so that'll get us to -17. Divide by -7, I just do whatever I've got. Divide by -7. Now I can see these 2 minuses are going to equal a plus. So my final answer will be k equals 17/7, which is a creepy fraction, but notice that it's positive, and notice that we're just leaving it as is. No mixed number business. Don't worry about that. Okay. Off we go to the next one. Example 25.4. Solve these all have pretty much the same format. Number times a letter plus or minus a number equals a number. Okay, so that has been consistent in all of these. Okay, same thing. Here's our letter. We find him. We say, okay, what's happening to him? We've got a multiplication and an addition. We take care of the addition first. The opposite of adding is subtracting, so I'm going to subtract 5 from both sides. Yay. -11p equals 12. Now we'll divide by -11. And this is the same situation as we had before. Right now the minus sign is attached to the -11, but when we write our answer, p equals -12/11. The minus sign comes out and floats. That's the right answer. Woo, we're batting 1,000. Okay. Let's try one with fractions. And I'm going to teach you a trick that John doesn't want to teach you yet. Now, we could do this exactly the same that we've been doing. We would add 1/2 to both sides, and then we would, well, we wouldn't divide by 1/5 because that would create a nightmare, but we could multiply by the reciprocal, right? But I don't want to do that because you know what? Whenever I see fractions in an equation, my first instinct is, oh my gosh, let's blow them up. I know, I'm a little bit destructive, but I don't like fractions and I would like to blow them up whenever possible. So we're gonna blow up our denoms. Notice that denoms, which is just short for denominators, it looks almost like demons, doesn't it? It's so close. The way that we do that is we find the least common multiple of the denominator, 5 and 2 and 4. Okay, well, we know that 2 goes into 4, so we don't have to consider 2 as a special case. Whatever 4 goes into, 2 will be happy as well. 4 and 5, that's going to be 20, isn't it? So watch this. What we do, and I'm going to use a different color to help you see it really clearly, we multiply each term by the least common multiple. So I multiply that by 20, that by 20, and that by 20. Okay? Because that's the least common multiple. Now, I can cancel top to bottom. 20 divided by 5 is 4. So I cross out that, and I'm going to multiply the old numerator by 4. Same thing here. 20 divided by 2 is 10. So I'm going to multiply the old numerator. I'm multiplying the old numerator by 10, which is what I get when I reduce this. 20 over 4 is 5. So I'll multiply the old numerator by 5. That's kind of tricky. I'm sneaking you in ahead of time because I don't want you to have to struggle along with the fractions, but we'll be doing that more and more to just get rid of denominators altogether. So now look what we've got. 4 times 1 is 4m, right? The m's fine, it doesn't change. 10 times 1, there's this minus sign, minus 10 equals 3 times 5, 15. I would much rather deal with this than fractions and reciprocals and all that crazy stuff. Just blow up your denominators and be done with it, all right? Add 10 to both sides. 4m equals 25, and then we divide by 4. And m equals 25 over 4. Right, because those cancel. Yay. And one more. This time we've got decimals. We're going to deal with those. So this is our last example for this lesson, 25.6. And we're told to solve this. All right, notice it does fit the same format. A number times a letter plus or minus another number equals another number. That's the same. What's different is we have decimals, and we don't want decimals, so you know what we're going to do now? Blow up the decimals. How do we do that? Basically, what we're doing is we're going to multiply these numbers by a power of 10. 10, 100, 1,000, 10,000. Whatever it takes to get rid of the decimals. So we look at these and go, okay, how bad of a problem do we have? This one we have 1 decimal place, 1 decimal place, 2 decimal places. Okay, so what that means is we have to move all the decimals the same number of jumps, all right? So we're not going to just change these guys by 1 jump and this one by 2. No, that doesn't work. We have to move by the maximum number of jumps required to get rid of all these decimals. So this tells us we have to do 2 jumps. And by jumps, I mean we want to move the decimal twice. That's the equivalent of multiplying by 100. Okay? So there's 2 ways of thinking about this. We're moving the decimal place 2 jumps to the right, or we're multiplying by 100, and that moves it twice. Every 0 in the power of 10 is 1 jump. So we're going to move it 2 jumps to the right, all of them. This one I have to add in a 0, right? That's going to become 40. This one, same thing, I have to add in a 0. That's going to become 20, and that will just be 16. So now I've got 40x minus 20x equals negative 16. Oh, I'm sorry, this shouldn't have an x. I made that up. All right, so then we'll add 20. Again, here's our x. Pay attention to that. Add 20 to both sides. 40x equals 4. Divide both sides by 40. And we get x equals, and let's see, we can divide this by 4 over 4, right? We can do that in our heads. And x equals 1 over 10. And just to be fancy, because our problem started in decimals, it's a great idea to give the answer in decimals too. So we'll write x equals 0.1. I would accept either of these answers as perfectly lovely. I always prefer fractions to decimals, but it does make sense to me that if you start with decimals, then you should end with decimals. So either way is good. All right, so this little trick to get rid of our denominators saves you the fuss and muss of having to work with the decimals. We could have just left them in there, but it just creates an opportunity for errors. Same with the one where we blew up our denominators, the last one. We could have just worked this with the fractions, but I'd rather not. We're going to learn to do this later, how to get rid of fractions and how to get rid of decimals in our problems. That becomes more of a thing later on, but I taught it to you early because I prefer to do it that way myself. All right, beautiful. That is the end of lesson 25, and I'll give you spoilers. The topic name for lesson 26 is more complicated equations. So more of the same. Okay, thanks, bye.